Hello and welcome back. Today we're going to be talking about Newton's second law. The first law describes that there is no change in velocity unless there is a net force on an object. If you haven't seen the last video on Newton's first law, net force, often written as F net, is the sum of all forces on an object. If an object is at rest or there's no acceleration, the sum of all forces on an object is going to be 0. But if there is a net force on an object, the velocity will change. Newton's first law dictates what will happen if there's no net force, while Newton's second law shows what will happen if there is a net force. So like I said, a net force means there's change in velocity. So F net means a change in velocity. I'm not saying they're equal, I'm just saying if there is a net force, then the velocity of the object will change. This also means that when there's a net force, there is acceleration. Because, if you remember, change in velocity is equal to acceleration. Those are the same thing. So, Newton's second law states that when there's a net force, there is acceleration. But it also says that F net is proportional to acceleration. Now that seems important. So, if net force increases, so does acceleration. And this is where it all comes together. F net equals ma. This is a crucial equation to know. In Physics 1, this is your child, this is your baby, this is everything you love. F equals ma is the most important equation in Physics 1. We check out the units involved with this equation. We've got mass, which is written as kilograms, times meters per second squared equals something. Kilogram meters over second squared is the unit for force. And this is called a Newton. It's very commonly written as just N. So, for example, I'm pushing something with 10 newtons of force to the right. Let's examine this equation a little closer. Mass is basically how much matter is in an object. It's also commonly referred to as a measure of resistance to acceleration. Resistance to acceleration. Now, if you watch Newton's first law, that should sound familiar. And that is because I described inertia nearly exactly like that. So what's the connection? Mass is essentially, in the scope of Physics 1, the inertia of an object. Since mass is resistance to acceleration, you can imagine that the higher the mass is, the harder it is to accelerate. For example, let's say I push a block with 10 newtons of force, and that's 10 kilograms. And I push another box that's 20 kilograms, also with 10 newtons of force. Which one will accelerate more? Well, there's more mass in the second box, so there's more resistance to acceleration. So, box 1 will accelerate more. And that should make sense intuitively, because the heavier an object is, the harder it is to make it move. One last thing about Newton's second law. Since mass is a scalar, acceleration is a vector, and force is a vector, force and acceleration must point in the same direction as vectors, with different magnitudes depending on the mass. Alright, that's it for Newton's second law. Stay tuned for Newton's third.